Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us continue our course, Principles of Steel Design, PSD. We are now on our part 1, module 01. It's about use and application of steel design in, or steel structure in civil engineering. So, topic, structural steel, use and application in civil engineering. I'm your professor, Dr. EYPEI ZANTUA. I am a civil engineer, mechanical engineer, and graduate of Taguig City University and a Japanese government scholar. So let us proceed with the topic, which we start with the objective of the course. The objective is to know that this course provides fundamental concepts, principles, and theories under structural analysis and design of steel elements in an structure. Okay. So, analysis and design of steel elements in a structure. So we have the list of topics to be discussed. So we have 8 parts actually, and right now we are on the first part. So introduction of the topic, not of the course. We already done with the introduction of the course, and now these are the subtopics relating to the part 1. So we have 5 of this, and we are on the first module, use and application in civil engineering structures. So in the current video, you must be able to understand the advantages, understand the disadvantages, and identify C structures for which the use of structural steel is applicable. C meaning civil engineering. So let us take on the more general view of advantages, the disadvantages, and identification of structures. And let us start with advantages of steel as a structural material. So we have the following: high strength. Of course, steel is a material with so much density per unit stress, so it can carry. And because of that, it is somewhat stronger than comparative material. So, and in fact, in the construction industry, steel is the most or the strongest material. Okay? And at the same time, most economical. So we can design, build a stronger material than steel, but on its normal forms, on its natural form, after making steel out of iron and carbon, so it is naturally stronger than other types of material. Okay? So aside from special types of material. So specialized type, we can, of course, get materials which are even stronger. So number 2, uniformity. So because this material is actually being studied volume of times, even hundreds of thousands of times, or over the world, and through centuries. Okay? So centuries, hundreds of literature, hundreds of years of research. Okay, so we can nowadays at the current level of technology, we can make component, an element that could have a uniform characteristic, which cannot be said about, for example, wood. Okay, so we can only get range of desired characteristic from wood, but still there is a what more accurate characteristic, level of characteristic, meaning the tolerance level. If I would order something, I would specify the tolerance of that characteristic. For example, the allowable stress. So it is usually could be uniform on one batch or one deliveries. Okay? So that's not possible on other type of, for example, wood. Okay, even on the same wood, if you cut off components one, components two from the same tree, there is a expected difference. For example, if you use a part of the wood which is farther away from the center compared to the part of the wood which is near the center. Okay, so the wood trunk. So we have what? The wood trunk, and then we have what? The center of the wood. So the characteristic in terms of allowable stress of those areas near to the center and farthest from the center, totally different. Okay? Totally different. The tolerance is big. That's what we have to expect. Okay? And also on the other material most common in the construction, which is concrete. Okay, batching of concrete. Batch meaning one single mixture, one single processing. So we can expect almost similar characteristic, but okay, for example, the batch is too big in quantity. Okay, for example, 3 tons. So as you set the concrete on a form, okay, on a form works, okay, on form works, there are form works to be prepared before you can set the concrete. Okay, so initially the concrete will be will have for example a greater amount of water, okay, because initial, okay? If the pouring process would cost you about, for example, 3 hours or 2 hours, so the later portion of the same batch of mixture of concrete would have somewhat different in characteristic, because it may have what substantially decreased amount of water already. Okay, so that's what we mean by uniformity. That's why it is listed here that uniformity is an advantage of steel. Okay. Elasticity, another advantage of steel. both because there are the three most commonly used material in the construction are steel, concrete, and wood. If we compare the elasticity of the three, it is an advantage for steel because positive and negative elasticity of steel is almost identical. Positive and negative elasticity. Meaning, if you compress and if you stretch, the characteristic of steel is almost given by a single formula. Okay, could be characterized by a formula which is proportional. Okay, because we are talking of elasticity, it could be what? Stress over strain. The formula is stress over strain. Even if we are going to compress or stretch the steel. See, that is not true with wood. Okay, compression and tension of wood are different. The same true with concrete. They have a different characteristic in compression and tension. So tension meaning you stretch. So that's why it is listed as advantage, because steel is a good material and you can expect the characteristic both in tension and compression. And because it is strong, so it is also strong in compression, so you can expect that it is also strong, similarly strong in tension. Okay, which are the disadvantages of actually the other types of construction material like wood and concrete. Okay, permanence. Okay, another advantage. So permanence of steel is always noticeable. Okay, okay, it's almost self-explanatory. So okay, and also the same is true with ductility. Okay, ductile. So it is not what? Brittle. So it would fail in a manner like plastic. No? Plastic characteristic on its failure. It will not fail in a manner like a glass, which is brittle characteristic. So it is important to know for us to have a failure as in a plastic characteristic, not as in a glass characteristic. That's why we are actually mixing some other plastic material, plastic component, fibers to glass so that the glass would not break easily as a brittle material. So meaning it is a disadvantage of glass. And because of the opposite, steel is not brittle, so it has a very good ductile characteristic. So number 6, toughness. Toughness is another important characteristic, which is again advantageous to the steel as a construction material. So it is tough. Okay, could handle so much What? It is actually simplistic explanation. Toughness is how much positive and negative loads, repeated positive and negative loads, or periodic positive and negative loads, it could handle. So steel has a very good reaction to that kind of load. Positive negative load meaning it would give compression load, then tension load, compression load, tension load, and so on. Okay, that is positive negative type of load, or positive moment, negative moment, positive moment, negative. So it is a good material in terms of this toughness. Of course, it would fail, but compared to other construction material, was a very weak toughness. For example, concrete. Concrete is a material that has toughness at its disadvantage. Okay, it's not tough. It cannot handle so many cycles of positive and negative loading. Okay, what are the example of positive and negative? Normal load, wind, for example, wind direction is continuously changing. Okay, so okay, if you take a look at, for example, bridge, and you use steel component, and therefore the direction of moving load over the bridge would be what? Back and forth, okay? And back and forth meaning moments, forces would be what? Repeatedly changing. So that is what we call toughness in the steel, to allow so many cycles of this type of loadings before it would fail. Okay. So number 7, additions. Addition meaning if you what? For example, you are using it as a component of a bridge, and you want to modify or you want to add an accessory to the structure. Okay, it's very easy to replace parts. Okay, usually these metal components or steel components are joined or connected by welding or bolt or rivets, so it could easily be replaced, some parts. So for example, one span, you can just replace a small portion by using plates and bolt it or rivet it on that particular area. Okay, unlike you are using what wood, it may be also possible, but there is a what forcing trouble and the capacity again of the wood. For example, the span is made up of a single unit of wood, and then you cut through a small portion and connect. For example, there's a damage, so you have to replace some portion of the wood, a span of the wood. So it is very hard to expect the same characteristic on that small portion. Okay, unlike in steel, because for example it is already a plate that you have to replace or you have to add another plate. It's very easy because you are going to bolt or weld Okay, so it's very easy to add. There are what problem in in handling the load by the material. You have to add structural elements to make it sturdier. Okay, so it's very easy. That's why it is an advantage. And other miscellaneous things like for example, steel is one of the material that is reusable, and after using it, it will become a scrap, and then the scrap would be delivered to the factory and recycle it. So this is a type of material that could be recycled on and on without limit, on and on. You can get almost the same characteristic from the scrap. Okay. Okay, so it depends on the process that you, of course, that you will do on the design and processing of the steel elements. So there are several processes that would get corresponding characteristics. So it will depend on that. So meaning recycling, reuse is a miscellaneous advantage, which is very good advantage, because in the construction there are plenty of potential wastage, and because it is steel, could be sold actually, okay, as an scrap, and that is not imaginable when you are using, for example, wood, scrap of wood. You cannot reuse it. You cannot recycle it. You have to plant another tree and wait for so long, more than 10 years. Okay, so another thing is concrete. How can you recycle, reuse? For example, a slab that you have to turn down. If you turn down a slab, how can you reuse it as a slab again? Okay, a slab for another place. Okay, so it's not possible always. So there are things. There are so many things actually. That's why steel is the second most used material in the construction. Okay, and several other important advantages, if I may add. Ability to be fastened together. So to be fastened together, for example, just like what I've said, we can use, as you can see on the picture, bolt, rivets, could easily be joined together, component per component, element per element. You can assemble a structure, a system of small elements. Okay. Adaptation to prefabrication. It's too easy. We can what? We can design, cut, weld, bolt it on the manufacturing floor, then just deliver on site. So prefab. It is easier. We can do it on other material, but it is easier because of the seeming precision tolerance and tolerance that is already learned from the past. So the skill that the construction discipline already gained from this type of material. So we are all aware of this, so could be easily adapted for fabrication. We just need what? Drawings. We just need the parts drawing. So it could easily be what? Parts drawing. Just the very simple example is the bolt. Okay, a bolt. You can source out a bolt from any other manufacturer, and it will do just the same. Okay, do its function just the same. So that's why it could be fabricated anywhere. So speed of erection, meaning it could be assembled faster than others because others like concrete needs curing. Okay, so after cutting, you have joining process, then it's now an assembly of structure. Okay. So letter D, ability to be rolled into a wide variety of sizes and shape. Another advantage could easily be structural shape and size. So you just have to pick the necessary design size and shape. Possible reuse after a structure is disassembled. Oh, that's is what I'm talking about a while ago. It is possible to reuse, recycle, scrap value. Okay, we have scrap value for steel. Very difficult to have a scrap value for wood. Wastage of wood will become waste. Okay, so ultimate recyclable material. So what about disadvantages? So there are also plenty of disadvantages. Okay, so let us cover this disadvantages so that we can compare. We can evaluate if the advantages would overwhelm the disadvantages. Okay? So number one is the corrosion characteristic, because it is a metal. It reacts with with oxygen, and therefore it could easily be corroded. As you can see on the picture, it is a ongoing construction, and not even finished. The construction is not even finished, and then there you go. You already have so many yellowish portion of the parts, and it's not hard to determine that those are rust. Okay, so corrosion. And number two, which is now nowadays being given too much attention, but that is only a necessary attention, is the fireproofing cost. Because one of the disadvantages is its characteristic against fire. Its characteristic actually against temperature. As the temperature goes up, the characteristic of steel substantially goes down. And you can also say the same thing with wood. Okay, and wood is even called light material, because with wood is just a fuel or fire. Okay, so steel is even better in terms of its characteristic against fire. But we are talking of another thing here. fireproofing, meaning the characteristic of steel being tough material, being strong material, will suffer substantially. Okay, so about 500 degrees Celsius to 600 degrees Celsius, the characteristic of steel will go down to about 70, 60%, 70 to 60%, okay, of the its specified maximum. Okay, so and that is what, lower than the working, maybe lower than the working stress. So it's what, dangerous with respect to fire. So if still get the experience 500 degrees Celsius, then the structure may be in danger or at risk of failing already. So what do you need to do? You need to do the fireproofing. So that is costly. Okay. Another disadvantages are susceptibility to buckling. As you can see on the picture, that is one example of buckling. So anyway, there are several types of buckling. This is one of this. Oh, this is one example of buckling. As you can see at the right of your monitor, another disadvantage, fatigue. Okay. So fatigue is also characteristic of the steel that only allows it to handle so much what, changing loads. Okay? So the load is changing. For example, even if the vibration is one type of vibration characteristic of load is different from just a normal long cycle changing of load. It is different. Okay? Vibration, the load changes sometimes instantly. For example, in what? During an earthquake. Okay, earthquake is one example of almost instantly changing load direction, and therefore steel is another material that is not good against those type of. Anyway, almost all materials are bad against fatigue. Okay, so imagine a piece of steel rod. You can, without even tools, you can break a steel rod by just what, doing like this, no? So bend it one direction, bend it to opposite direction, and then you will notice how many times you bend it, back and forth, and it will fail. Okay, it will break. Okay? So number 5, brittle fracture. So steel is a ductile mostly, but it will come to a point that ductility reaches its limit. So after that, it will what, become a brittle. Okay, so example, we have an example here. I think last month about 2 weeks ago. So we have here 2 weeks ago, we have a bridge that suddenly collapse. A bridge that suddenly collapse. Okay, and as you can see, the bridge is what? Steel structure. You can see. Okay. Top view on your left side and side view on the right side of your monitor, and you can see the components buckles. So this part, so there's a buckling here, some buckling, and there's a buckling here. Bucket. There is another buckling type, what we call torsional buckling here. Okay. So it did not fail as a, what I'm talking about, it did not break. Okay, it did not break. It is still one piece, but it buckles, and they are still connected, but most of the components buckles. Okay. So due to fatigue, okay, and buckling characteristic. Okay, so it's quite possible if the material reaches its fatigue capacity. Okay. So appearance of typical fatigue fracture surface. Okay, so we have what? This surface, the complete surface in picture. This is in diagram form. We have initiation part. So we have initiation part, fatigue crack. So fatigue crack. So up to this point, up to this point, up to this point, fatigue crack. Okay. And then catastrophic fracture. So catastrophic fracture up to this part, up to this darkest, somewhat dark part component. So we have, so you will notice here the texture is different starting from this point. So this texture is different from this texture. So this one, okay, and also different texture characteristic here. So that is an initiation part, initiation, fatigue propagation or crack propagation, catastrophic fracture. So three parts, okay, typical fatigue fracture surface. So we can compare what can we expect if one is brittle and one is ductile. So this one, it breaks uniformly or random, not of course not beautiful surface, but almost almost uniform. What I mean by uniform is that you can observe the other set, it also breaks, but there is a cone and cup. This is a cup shape, cupping shape, and the other one is cone shape. So cup and cone, like that, no? Cup and cone. But on the other set, this set, what surface just break without cupping and without making a cone. Okay, and you'll notice the what? The diameter here did not get smaller. Unlike here, the diameter somewhat get smaller here, somewhat get smaller here, and that is what we call actually necking. There's a necking, neck, okay? There's a necking that is clearly observable here. So there's a neck. Okay, here you cannot see necking. It just breaks down. So it is a dangerous type of characteristic because it just breaks. This type of breaking is dangerous for us in the structural sector because this will just collapse abruptly without any warning. So this one, the meaning of warning here is that you can see, you can observe that there's a necking. So as soon as you observe something like necking, immediately you can what? You can discontinue the use of the structure. Okay? You can stop the use of the structure, like the bridge. Imagine if an engineer observed that the that the bridge has some of its part with necking, but we cannot we cannot see necking, but this is what? Buckling. There's no necking here. No? There's no necking. There's no necking. So necking, the size, the dimension, what became what? Smaller because it what? It stretches. So if the component is held in tension, so it will stretch, and therefore the cross-sectional area will what? Will somewhat become smaller compared to the original. Okay, so that is the difference. So you cannot see necking here, the same diameter, or the same diameter. So that is what we call. So this material is actually brittle. So this material is ductile. So brittle, ductile. Okay, so the fracture could tell us the characteristic of the material. That's why it is important for the material to be tested so that we can actually see what is the characteristic of our steel. Is our steel brittle or ductile? Civil engineering structures now. So let us now go to the practical examples around us or around the world. Okay, so for which the use of structural steel is applied. So where in the world we can find application of steel structure. So there are so many things. So there are popular ones, there are tourist spots, there are so many things. So let us mooring mast, number one. So it's possible to use structural steel as a mooring mast because what? It would what? The application requires back and forth motion of loading, okay, or the load characteristic gives us back and forth motion. Another application, pedestrian bridge. Number three, roof framing, ballparks, trusses, okay, steel joist, okay, steel joist. Steel joist is the part that is if we are using the floor, so steel joist is the part, wherein now it is now prepared for what? For the top surface. So if the steel components is for roof, so steel joist is the part wherein the actual roofing would be connected to this element. Number seven, regular shape building, long span beam or trusses, steel dome, and round arch walls. So those are just some of the example. Let us just browse through some of the examples. There are so many things, hundreds of these, thousands of these examples around the world, even in our country. Plenty of this. So let us just browse through So as you can see, this is what we call mooring mast application. Okay, you can see there is a what? Airship. Airship is what balloon that could be used to transport goods for a human being from place to place. So those are being popularly used before, but I think now the level of technology for aircraft is so much that we are instead using airplanes, helicopters, rather than airship. Okay. This is the what? The top portion. So the tower portion, that small part there. The top of the building. So this is what. So instead of what? Because this is an airship, it is what? Better for it to be moored in a mooring mast rather than park it in what? In airports. So it's how they park the airship. Okay. So Empire State Building, not Empire State. So I say what? Typo error. Empire State Building in New York City. Okay. Pedestrian bridge. So like this one, you can see the steel structure, truss members of joist and what? Beam support underneath. So trusses here on the side and the roofing, and we have what? Joist and what? Beam, major beams, so on. Pedestrian bridge alone. We have so plenty of pedestrian bridge in our country and near our area. There's a pedestrian bridge that we usually use in what? Bikutan interchange. Okay, made up of steel. Okay. So rope framing for school. So rope framing, we have structural application like this in front of our school. But now you will notice that building is now what? Demolished. They demolished that building in front of our school. No? So that whole big building that include our gym, our basketball court, they already demolished the whole building. And that building is what? Steel framing, steel structure. It's look like having what? Post, beam, rafters. So these are rafters. And then what? Joist. So these are the joist. These are the joist. This one, this one, this one. So these are the rafters. 1, 2, 3. So these are the rafters. Okay. So we can say that these are the chords. This one, these are the chords. Take note of the name of these components: chords, rafters, joints, and for bridge we have stringers. When you are walking on top of the pedestrian bridge along the Bikutan interchange, you will what? You will see the what? Skyway over it. So the skyway is there, and walking through the skyway, you will see that you are what? In perpendicular, no? We are walking in perpendicular with the direction of the skyway. And because of that, it's very clear to see the stringers. No? Stringers are the big beams. Okay, so there's a big beam there that supports the skyway. Okay? So that is what we call stringer. Okay? And on top of the stringer, we have what? We have girders. Okay, so again, we have what? Trusses application. So you can see there are plenty of plates and bolts here. So many to say there is a what? Connection. So one piece is connected to another piece. Okay, so this must be connected, and then there are plenty of plates and bolts in order to get the desired strength of the connection. Okay, so you have also the connecting plates here, and that is what? Bolting the trusses to the what? The beam. Okay, so this is what application on what gym or ballpark. Ballparks in the United States are big enough, but sometimes they are what? Covered, or if not possible because of a uh, huge size, they will just cover the stands, meaning the area where the people are watching the games or the sports. Okay. Direction of rope trusses. So there are plenty of trusses components here. Okay. Plenty of trusses. Is while we have what? Cords, lower cords, upper cords, and we have what? Again, trusses elements joined by plates using bolts or rivets. So trusses, direction of steel joist. The joist would be the next component here. Joist could be used in here, flooring, for example, second floor, and also for the roofing. That is steel joist. But right now, these are what? Are beams, cords. Okay. So, Puerto Europa, Madrid, Spain. So steel structure. It's very hard for other material to have what? A high-rise building which is intentionally shaped irregularly. Irregular shaped buildings like this one. Very hard. So how many floors are there? So if you can see, you can count here 1, 2, 3, 4, 5, 6. So about 6 floors. So I don't know the actual count. So you can see here, so there are so many. So 1, 2, 3, 4, 5, 6, 6. This is another 6. This 6 times 4 is 24. So about 24 in height of the building. So maybe 20 floors. Okay. If this is not steel structure, it's very hard to do because it is irregular shape. Okay. So long span beams or trusses. One half of this particular application, okay, 170 feet. This is feet clear span. So there's no feet. 170 feet clear span. Clear span meaning there is no intermediate column in between. So 170 is about what? 170 is about 50 meters. That's long for a clear span. Okay, that is about 50 meters. 170 feet is about 50 meters. So the standard or the usually used column distance for a building, okay, for a residential building is about 6 meters, and this is 50 meters. Take note. So one column to the other. Okay, so one column to the other. What is the distance? 50 meters. Usually, it is desirable to have a maximum only of 6 meters. Very common, popular are what? 4 meters, 5 meters. Okay. Distance between columns. Here, 50 meters. Okay. So this is what Athletic and Convention Center, Lehigh University, Bethlehem, Pennsylvania. Okay, so Bethlehem Steel Corporation. So steel dome. Okay, dome shape. So instead of trusses, there are what? Many components, elements, creating what? Triangles. Because triangle is the strongest assembly of component. Okay, smallest unit, that is the strongest, smallest unit, triangle. So you can see so many triangles that forms the dome shape. Okay? So it supports the shape of the dome. Steel domes and round arch hall at Exhibition Center, Leipzig, Germany. So take note of the what? The post and columns, steel columns. It's not straight up, it's not vertical. It is now what? Arch. Arcing. Arc. Arch. Okay, so you can see so many components, okay, that assemble into what? Arc shape. There are so many. So in 3 dimensions, okay. So that's the end of the current lecture video. So before that, we have to solve a problem that you can give your comment briefly in your opinion. Number 1, do you have application examples located in your home country? Give at least 5 examples in order for you to answer question 2 to 4. Okay, so number 2, what sea structures have you seen in the past that could be classified as application of structural steel? Number 3, what are those in terms of structural elements? Are those girders? Are those stringers? Are those columns? Are those joists? So those are the structural elements. Okay. So in terms of structural elements, we are asking you to answer that the number 3. So what is the difference in number 2? The name of the structure. For example, Bikotan pedestrian bridge. Okay, so that's the name. Okay. So in the number 4, where are those located? Okay. Can you give us an idea, city or country? So give the city and country, at least. Okay. At least those things, city and country. No need to give the county or barangay or street. So just city and country. Okay, so that's all about this particular discussion. Hope we learned about advantages, disadvantages, and the application in particular. So we talk about advantages and disadvantages because we would like to see the advantages of steel in those applications. As you can see, in those given application, we are having or getting the idea that steel component, steel elements are very important. So take a look at these steel elements, okay, that make up the arch, that make up the dome, steel elements that make up the possibly this is cord, no? And the cord is what? Truss. Okay. So make up the irregular shape building. So we have what? So many different steel structure there. Truss component, column. Okay. Okay. So okay. So we have what? Okay. Easy connection, construction, easily connected, so rapid assembly. Okay. So those are advantages. Okay. And because of uniformity, okay, so those things are the characteristic advantages of steel: uniformity, strength, ductility, okay, elasticity, toughness. Okay, so I hope we learned something in this video. Again, please answer this question and post your answer on the comment box below. Again, this is Dr. EYPEI, preaching engineering for nation building.